Okay, finding the domain of square root functions. We're going to take the radicand out and we're going to look at what are the conditions to keep the radicand either positive or 0. So negative 5x minus 60, we want to keep that greater than or equal to 0. So to find the conditions that will keep this greater than or equal to 0, we're going to solve for x. And once we find out what the x's that work for this, we'll call those the domain values, the numbers that are all possible input for the function. So I'm going to add 60 to both sides to begin the process of isolating my x. We'll get negative 5x greater than or equal to positive 60. Then we're going to take our negative 5x greater than or equal to 60, and we're going to divide both sides by negative 5 in order to get this to become positive 1x. So we will get 1x, but because we divided by negatives here and here, we get a sign change. So instead of a greater than or equal to, it now becomes less than or equal to, and a positive divided by a negative will be negative, and a 60 divided by 5 will be 12. So x is less than or equal to negative 12. So what we're going to do here is put a number line up here, and we're going to put in our negative 12. And since there's an equal sign, we're going to include it by putting a solid dot. And less than means we have to use this left side, so we're going to shade in the left side. So we'll say our domain now is everything on the left side, which is negative infinity, all the way to negative 12, and we will include the negative 12. So this will be all the usable numbers for this equation, or should I say the usable input, our domain. Now, for number 5, let's take 18 minus 3x and set that up greater than or equal to 0 and find out the conditions that will keep this true. So let's isolate the x, minus 18 minus 18, and we'll end up with negative 3x is greater than or equal to negative 18. Now, taking the negative 3x greater than or equal to negative 18, we're going to divide both sides by negative 3 in order to get a 1x. So negative 3 divided by negative 3 gives us 1x. And because we are dividing both sides by a negative, the sign will change. So instead of a greater than or equal to, we'll have a less than or equal to. Negative divided by negative, positive, and 18 divided by 3, 6. So x is less than or equal to positive 6. The graph of that looks like this. There's 6 on the number line. We're going to include it because of the equal sign. And less than is everything to the left. So we'll say our domain is from negative, the left side, anything on the left side here, all the way to 6, and we'll also include 6. Now, number 6 here. We have here 18 minus 4x. We want that to be greater than or equal to 0. Okay, so let's solve this for x. Minus 18 on both sides. This will give us negative 4x is greater than or equal to negative 18. And then we'll take our negative 4x greater than or equal to negative 18, and we're going to divide both sides by negative 4. As a result, we'll get a 1x, and here we'll get a sign change because of the dividing by negatives on both sides. So we'll have a less than or equal to. Negative divided by negative is positive. Now 18 does not divide, so our 4 does not divide evenly into 18. So I'm just going to simplify this fraction by dividing by the greatest common factor, which is 2. That'll become a 9 over 2. Now the graph of that looks like this. This is 9 over 2 here in the middle. Kind of out of room. And since it's included, we'll put a dot here, less than. We'll graph over here. So this is our domain. It's kind of out of room, so I'll put the domain here. So the domain will be negative infinity with parentheses, all the way to 9 over 2, and then close parenthesis. Okay, and finally, number 7. We're going to take the radicand, which is the 4x, and set it greater than or equal to 0. Then we're going to take the 4x greater than or equal to 0 and divide by 4. Now, 4 divided by 4 gives us our 1x. Since we're not dividing by negatives, this stays greater than or equal to. But 0 over 4 might be a little bit of a problem. Well, anytime you're doing the division and 0 shows up, there can be a problem. So let me show you a way of remembering. Okay, 0 over a number is, or any non-zero number, this one is okay, because that one finally equals 0. But whenever you have a 0 divided by another 0, or a number divided by 0, these two situations, there's no answer for this. Trying to draw sad faces. So there are no answers for this. And the way I help my students remember these 3 conditions here, the good one and the 2 bad ones, is that if you have 0 on top, that's okay. But if 0 is on the bottom, that's a no way. Okay? So 0 on the bottom, no way. 0 only on top, that one's okay. Okay, so this will become 0. And so the domain for this will be, let's look at the graph. This will be 0 right here. 0 is included. And everything greater than 0 will be everything on the right. So we'll say our domain is from 0, including, and then the positive infinity means everything to the right.